Okay, Mr. Hafiz. So, come back already. So, I will start a whiteboard, Microsoft Whiteboard. If you guys don't have it, I think you guys can also install. Okay. Uh, I am starting Microsoft Whiteboard. So, collaborate on wherever everybody can edit. Yes. So, if Mr. Hafiz, you have added the whiteboard, if you can see the whiteboard, then you can write also on this whiteboard using mouse, or you can add your text also. Okay. So, if you can add your text or you can write something, then please try and write down the parameters which you just read from the papers which you just have searched. Okay.
Doctor, what I can write? I can't write the white in whiteboard.
I cannot, huh?
Hmm.
Let me check. Welcome to the whiteboard. Next, next, next. Uh, Maybe I need to give you access or something. So,
Because I'm using a
yes,
browser, I'm not using
I see. You are
apps.
a guest. I see. I see.
I as a guest,
Okay, okay.
not
So,
in the organization.
okay, okay.
How about I have
It's
download
okay, okay.
the paper.
Can try. Yeah.
So
Keep
I
trying.
put to WhatsApp group.
Okay, can also.
Yeah.
Nice. But
Okay, where
can you see me writing?
I can see your writing.
Oh, can see.
Uh,
Okay.
cannot see. I cannot see.
Cannot see also.
Yes,
Oh,
it's
okay.
blank.
Okay, okay. I see. Okay, so never mind. Later on in the next class, maybe you can install and we can continue. No problem.
I have it installed, but I cannot join because I'm not in the organization. I use
Oh,
a single
uh, do you know
the organization what UMP not add me,
in the email?
not add
Uh,
my email to the organization. So
do
I'm
you?
not in the organization.
Wait, who can bypass the everyone? Save. Okay. So just now I change. Now I think maybe you can see. Just now I change everything. You can bypass lobby now. Uh, Allow micro entry, provide card option, save. Okay, now so I think maybe you can guess mute for spotlight for everyone, make an attendee. Spotlight for everybody, make an attendee. Oh, change. Okay, okay. Okay, now make a presenter, remove from the spotlight. This is my mirror. Okay, now you should be okay. Uh,
Wait. I
hmm.
got a message. You spotlight your video is highlighted for everyone meeting. You an attendee. You won't be able to share content or facilitate. I
Oh,
can't.
so,
I cannot. Uh,
hmm.
I cannot.
So UMP did not give you any email also until now, huh?
No. Yes.
Oh,
Yes.
okay. Understand.
So it is limited.
Yes.
I can join because I'm not in the organization. My email.
Understood. No problem.
So maybe
You cannot also present. Can you present or cannot? Uh,
wait. Cannot. Only meeting organizer and presenter can share.
Who can present everybody? Make a presenter. Okay, I make you a presenter. Now you can try. Make an attendee. Yeah.
Okay. Wait. Okay. I just shared the paper
Okay. Okay.
in the
Uh,
WhatsApp group.
I want to add you separately. Uh, how to add a person separately? Channel, my channel. Anybody can post. Okay. Analytics. Channel setting. Class notebook. Very complex. Microsoft Teams is very.
Yes.
How to add you now in files,
Easy to use.
meeting notes. Mm, okay, never mind. Okay, so you just WhatsApp me already. Okay, can WhatsApp me? Camera on, share me.
I already was.
Okay,
But look,
okay,
why is it so long?
okay, no problem. So, Mr. Office Paper. Uh, Paper, Mr. Office. Do you have access to Unify in your home?
Yes, using not Unify,
Yes.
StreamX.
StreamX. Oh, StreamX only. So,
Only
uh,
in this area it doesn't have a Unify.
yeah, only Kuala Lumpur has Unify only. Kuala Lumpur only.
Yeah, in the big in the city only. Big
And they want to start 5G already.
wow.
Me also a lot of problem internet. Never mind. Okay. So just can you tell me just no need to share also. Did you find any different parameter?
Different factor.
Hmm.
Okay, I'm why is it so long to loading?
Maybe very,
Paper,
very
paper. Okay, the paper title is Stretching Induced Surface Characteristic and Material Removal Mechanism in Rotary Ultrasonic Surface Machining
okay.
of CFRP.
CFRB,
So the
carbon fiber
carbon
reinforced
fiber reinforced
plastic.
plastic
Oh,
composite.
good, good. So this is
So the
your target,
parameter is
target.
this is the title.
And they use
So
they
and then
different parameters to optimize or to check the material removal rate, right? The final output is
to check the material workpiece.
material.
The stretching on the workpiece when the
Scratch.
tools,
Oh, scratching. Huh?
yes,
Oh,
scratching on the workpiece.
scratching. Okay.
Uh,
That's very
so the
unique, no?
workpiece
You-
is CFRP composite
Okay.
workpiece.
Okay. And which parameter they try to change or modify, like power, rotational
Uh,
speed?
the let, wait.
Yeah, yeah. Take your time. Don't worry.
So we study the effect on machining variables, which
Yeah.
is ultrasonic, power,
Ah,
tool rotation speed,
hmm.
feed rate, and depth cut.
DOC, depth of cut. Okay. Depth of cut. Okay. And feed rate. Okay.
So
And
the using a Bose cutting force, which is a feeding directional cutting force, axial directional cutting force.
okay. They measure this cutting force also.
They're using
Oh, they're using it.
the
I
uh,
see. I see. Nice, nice.
so the
So now,
parameter using tool rotation speed, lower feed rate, and lower depth cut,
hmm.
and higher level of ultrasonic power led to lower cutting force and
Oh,
higher surface roughness.
oh, higher surface roughness. Okay. So if high power and other parameters are low, then the surface roughness is very high, which is not good, I guess. Which is
So
not
it's not
target.
good.
I'm not sure whether they want to target high roughness or low roughness. Means more scratching or less scratching.
Oh,
Yeah. Okay. Never mind. Never mind. Okay. So it's a very good paper which you downloaded. But now you know already how to hunt for parameters, how to grab parameters from a research article, right? And then
yes.
what they're looking for, whether they're looking for which properties, MRR, or this and that. So now,
Uh,
if you want, then you can basically go into the field of research in machining of ultrasonic, actually. So now you are eligible, actually. Okay. What you will do later on in your
okay.
let's say, just for an example, if you want to do PhD in ultrasonic machining, okay, then you will download.
Total.
Oh, yeah.
I cannot hear you.
Okay, okay. I think what is happening to the internet? Let me check the internet. Internet, okay. I think your connection.
Okay. Maybe it's my internet because I cannot send the paper
It's
to
okay.
my side.
Oh my, I'm sorry to hear that. Uh, uh, yeah, I think you
It's
will
not.
not be able to hear.
Yeah, I
Yeah,
can hear.
I can also not hear you actually.
You know,
Mm, mm, okay, never mind. So today's lecture can maybe I can send you Dr. Lukman video maybe because I don't know how to give lecture today if no internet. So so I okay what I do is I send you the Dr. Lukman video, okay, and
Dr.
then
Lokman.
yeah, I think Dr. Lukman video, and then mm, we start the same process of teaching and learning from Monday next week, I guess.
Oh. So today I will continue this the lecture continue with Dr. Lokman.
Yeah, if you can hear me, then I can continue. But if you cannot hear,
I can hear you, but
can
sometimes cannot.
okay.
But
So
now just now I can hear you.
just now you can hear me.
Yeah.
So the moment you cannot hear me, then let me know on WhatsApp. Okay, I will
Yeah.
continue
Okay.
now. I
I will
continue
let okay. You
until
can get.
yeah, and then the moment you cannot hear me, then let me know. Okay, so you can
Okay.
switch off your mic. Maybe it is also causing lag or something. So maybe I stop the spotlighting. Okay, make an attendee. Okay, mute participant. Okay, okay. So if any problem, let me know on WhatsApp. Huh? So yeah. So Mr. Hafiz has now, Alhamdulillah, already started looking into papers. That is very positive, and now he can find different parameters for ultrasonic machining, different materials that they are using, and what is the final output or what is the final important property that they want to improve or achieve, such as MRR, such as scratching, such as cutting force. So, so this is the slide in which I wanted your input. Okay, so I already have got Mr. Hafiz input already here. Okay, so this is something that I wanted to write on the whiteboard previously. Okay, so this slide is finished already. So what we have completed just now for ultrasonic machining is the parameters and the output and the different levels that can be read from the research papers. Okay, so after now that you have completed ultrasonic machining, you are now capable of basically downloading ultrasonic machining papers. You can download a lot of papers. Let's say you can download 1 2 3 to 10 papers. Okay, you can target a specific material. Let's say you want to do research or ultrasonic machining of titanium implant materials, biomedical materials. Okay, so what you will do is on the Google Scholar, you will write ultrasonic machining, okay, in full form, ultrasonic machining full form, and then you will write capital letter A and D and operator, Boolean operator, right? And Boolean operator, and then which material you want to select for your PhD or for your research is such as titanium. So when you are going to apply these two keywords, then you will get a list of papers. When you will get a list of papers, then you will download this list of papers. Okay, and in front of each paper, you in the Excel sheet, you can basically mention the important parameters and what is the property that they want to improve also. So when you make this whole database of all the papers, this is the database of all papers related to ultrasonic machining and titanium. When you are going to make a database, then this database is called your literature review. Literature review table. And if you are going to write it in written form, then this is called literature review. In the form of paragraph, in the form of pages, in the form of words, then this is called literature review. And the table that you are going to make is called literature review table. So maybe I can show you an example also. So that you can understand how a literature review table looks like. Okay, so here is an example of a literature review. Okay, and is there any table or not? Yeah. So here is a table. Here is literature review and here is table. Okay, you cannot see this maybe. Uh, let's say in this table I basically use different types of lasers. Okay, and what is their properties? So this one I get from different papers. Then in this table, okay, this is different types of biodiesel material, then the parameters, and what happens to the parameters. This one increase, MRR increase, depth of cut decrease, surface finish increase or surface finish decrease. So this is how we can make a literature review table from the different papers that we are going to read and write and cite also. Okay, so this helps us in making literature review table. Okay, so this was a little bit of a introduction to ultrasonic machining, and obviously yes, we cannot go into extreme details of what each and every research paper is telling us, but however my job is to make you guys comfortable, that so that when you read and when you start downloading the ultrasonic machining papers, then you are able to understand and you are able to know the parameters, process and results, or optimization techniques and results that you have obtained in the paper, the authors have obtained in the paper. So let us move to a new topic now, which is jet machining, or sometimes also called as water jet machining. So we move on to the second part, or the second type of the process, which is water jet machining or jet machining, sometimes referred to as jet machining. So in jet machining, obviously, what is jet? Jet refers to something which is moving at a very high velocity or pressure, and it strikes a material. Jet is basically a combination of high pressure, high velocity. Okay, and that jet has some kind of a direction. So it has some type of direction. Okay, high pressure, high velocity, and some type of direction. When these three things, when these three things strike a material, okay, together, if I have water, okay, and that water has high pressure, high velocity, and single direction, then it strikes my material, then that water has so much power that it can create a huge hole and it will remove the material also. And then the water jet passes through. Okay, so this is the concept of jet machining, to pressurize something so fast and with so much energy. Okay, it should have very high energy as well. It should have so much energy that when that energy strikes the material, it removes the material completely, immediately. Okay, so in jet machining, high velocity stream of water or water mixed with abrasive material. So what we have the options? Option number one is we have water only. Okay, liquid only. Option number two, we have water plus abrasive. Okay, just now we already learned we have got different types of ceramic abrasives such as corundum, alumina, silicon carbide, boron carbide, something like that. So we have got water jet cutting, or we have got water mixed with abrasive. Okay, this is called abrasive jet cutting, and this is directed to the workpiece to cut the material. If a mixture of gas and abrasive particle is used, then this process is called abrasive jet machining. Okay, so we have got water jet machining. If I'm going to add abrasive, then this becomes abrasive water jet cutting. And then if I only have gas, then this is called abrasive jet cutting. So these are the three different types of jet based machining which are used. But the underlying concept, the underlying phenomena of machining is same. So let's take a look at water jet machining. So in water jet machining, obviously we use fine, high pressure, high velocity, faster than the speed of sound. So faster than the speed of sound. So I forgot the speed of sound was how much, 300 or 333. Speed of sound was 343. Okay. So faster than 343 meter per second. Okay. 343 means Mach number greater than 1. Okay, supersonic. Stream of water is directed at the workpiece to cause slotting of material. So basically we are creating a narrow slot. So if I have got my workpiece, okay, and I create a very narrow, I remove the material in a very narrow region. This is a narrow region. Then this means I am slotting material. It means that by this technique I can create precise, thin cuts. I can slice like a knife. I can cut metals and I can slice metals like a knife. Okay. So let's visualize how does this water jet machining looks like. Okay. So I will open the voice. Okay. I will increase the sound and then I will decrease my sound and then I will start the video. you can see this is a very complex. So if you can see here, what are these? These are abrasives, and these abrasives are going to be mixed with water. So this will become abrasive water jet machining. Okay, this will become abrasive water jet machining, and the part that they want to make is a impeller, and you can see that the impeller has a three-dimensional design and it has got very intricate shapes. So in order to create a complex, so from this video what I see is the part is very complex part. Okay. Then you can see the pressure. So the pressure in terms of kilopascal is I'm not sure, but it is written in terms of kilopascal. The reading shows kPa. Okay. Then, so this is the control. Okay. So the machinist and machinists have some type of expert knowledge, and then this is the maybe some designer. So she is basically designing this on a C master cam. Master cam is CAD. No, CAD is used to create a computer-aided design model. She is using computerized machining software. I forgot the name. CMM something. So Mastercam is used to basically create a machining path for the tool. So this software is used to create a machining path for the tool. Okay, so you can first visualize how the machining or the abrasive tool will rotate with respect to the origin or with respect to the workpiece to create this type of complex part. And you can see that the water is also coming out and the water jet is leaving through the hole of the or through the slot of what it has created already. Then he is putting the workpiece onto the work table. These are abrasive water jets nozzles. Clamping the sorry. Then clamping the workpiece, and now the water jet machining has with abrasive going inside. There is abrasive is going pressure increase and water jet machine. You can see the abrasive going inside also, and now the water jet is basically slotting the material. High pressure pump is required, and now you can remove the material how precise and complex geometry is created. This is carbon fiber reinforced plastic. This material is carbon fiber reinforced. Okay. So water jet machining, you can see, can be used to create very precise structures. So water is the most common fluid used, but additives such as alcohol, oil products, and glycerol can be also added to further improve the fluid characteristics. The pressure is 150, so pressure is equals to 150 to 1000 megapascal to produce jet velocity of 540 to 1400 meter per second. That's a huge amount of velocity. The flow rate is typically 0.5 to 2.5 liter per minute. The jet has a central region surrounded by fine mist. So nozzle, central pressure cores, they've got bubbles in the liquid, drops in air. So basically, obviously, if the water is moving very fast, then some amount of mist is created. Water vapors are also created, which surrounds the whole water jetting environment. So the typical work material involves soft metal, paper, cloth, wood, leather, rubber, plastic, and frozen food. If the work material is brittle, it will fracture, and if it is ductile, it will cut very well. So it is very important for us to have ductile material. So the workpiece limitations that it will only cut soft or ductile material. Why brittle material cannot work here? Brittle material cannot work here because when we talk about brittle material and when we talk about the stress and strain graph, okay, they do have only limitation until here. This is brittle material. So if I look at the area under curve, okay, then this area under the curve is called the toughness, and the toughness of brittle material is very low. When the toughness of brittle material is very low, it means the ability to fracture is very high for brittle materials because they cannot absorb energy, because water jet machining impacts uh, huge amount of energy which brittle material cannot absorb. Cannot absorb, leading to sudden onset of failure. So this is what happens when water jet machining is used on brittle material. Okay. Now there are special design considerations such as the typical nozzle is shown below. The orifice is made up of sapphire material and its diameter ranges from 1.2 millimeter to 0.5 millimeter. So we've got this nozzle type of structure and it has got an orifice, and this orifice is made up of sapphire material. Beautiful. Sapphire is found on iPhone home button usually for sensing the touch. For sensing the touch on the home button, iPhone 5s and iPhone I think 5 Touch ID is using material sapphire. Because it is able to withstand high velocity, high pressure, and it will not break, it will not fracture. That is why sapphire material can be used. on the orifice. Okay, so this was all about water jet cutting. So the same is the case of what abrasive water jet machining or cutting. As I told you, a narrow focus water jet is mixed with abrasive particles. So number 2 is abrasive water jet cutting, and it is mixed with particles. Okay, the presence of abrasive particles in the water jet reduces the cutting forces and enable the cutting of thick and hard material. Okay, so this type of machining process overcomes the limit of water jet machining. So abrasive water jet machining specifically overcomes the limit workpiece limitations in water jet cutting because of additional cutting by the aid of abrasives. So now water also cutting, abrasives also helping in cutting. That is why the workpiece limitation is overcome, and now we can use it can be used to cut thick 80 millimeters. Wow, 80 mm, 8 centimeter of plate can be cut, and hard steel can cut also. In water jet machining, we can only cut aluminum or ductile material, and the speed of velocity of steam is 90 meter per second, about 2.5 times the speed of sound. This one I don't know why they are writing 2.5 times the speed of sound. So here we've got a separate hopper or mixing chamber, and in the mixing chamber we put the abrasive material as we just saw in the video also. So abrasive water jet cutting process was developed in the 1960s. They cannot withstand high temperature for stress distortion of material regions as a wood, composite resin, like cement, glass, stone, and titanium alloys. The commonly type of abrasive material used. Yeah. So which types of abrasive we can use? The type of abrasive that we use is again very famous corundum Al2O3. We use silicon carbide SiC, and size of the grid ranges from 60 to 120, and difficult to cut materials, and we can cut ceramics. Workpiece can be ceramics, uh, glass, stones. So you can cut stones also. Titanium alloys. Titanium is very high hardness titanium alloys, something like that. So these are the things that we can easily cut using abrasive water jet cutting. We need to see, yeah. So there is a video, I think, here. That we must watch.
High-pressure water alone can slice materials as hard as glass. But throw in a little fine sand, and it can cut through pretty much anything.
By adding abrasive to the water, you're increasing the strength of that water over 100 times.
So he is saying that if we add abrasives to water, then we are increasing the strength of the water jet about 100 times. Okay.
An abrasive high-speed water jet even chews through incredibly hard ballistic ceramic and glass used in the most advanced blast-resistant armor.
It's the unique characteristics of water and how erosion works. Bulletproof glass will stop a 50 caliber shell at 200 feet, but yet we can erode it with a water jet just like we would a standard piece of plate glass in your house windows.
The water will also drill right through to the steel guide under the material. In fact, the only way to stop the water is with more water. A 4-foot deep trough of water helps absorb the 2,400 mile/hour jet before it bores a hole in the floor. What's the upside to using water as a cutting tool? Just about everything. Water's inexpensive and reusable. It makes a very precise cut. And since it does its job without heat or friction, the cutting edge doesn't distort the material, and it never gets dull.
So one important thing he is telling is that the cutting edge does not distort the material. So where during cutting, they are saying that the water jet moves through, the abrasive particles moves through. Okay. The abrasive particles move through, and the final shape of the product is that you've got a very sharp, cornered, without any distortion, our sample. But it can also happen that if we use laser, then sometimes we get a distorted or curve width cutting. So this happens during laser cutting, that we get curve width, KERF This is basically a width excess MRR done, material removal done on the corner. Okay, so this is a problem in laser cutting. However, it is very nice here in abrasive water jet cutting. So this was all about abrasive water jet cutting and its advantages, and it cuts like a piece of knife cutting smoothly. Okay. Okay. So abrasive jet cutting. Now, as I told you, there are three types. Number one, water jet cutting. Number two, abrasive water jet cutting. And number three is abrasive jet cutting, in which we just use the abrasive in gas. Okay. So we are now using abrasive jet cutting. Abrasive jet cutting, AJC. In abrasive jet machining or cutting, the fine abrasive particles are accelerated in a gas stream towards the work surface. As the particles impact the work surface, they cause small fractures, and the gas stream carries both the abrasive particles and the fractured wear particles away. So basically, the function of gas is that it allows the particles to flow at a very high velocity. So it is basically a transport carrier, and then when it strikes, when the particles or abrasive particles strikes, then the same gas, when the abrasive particles strike the material, then it fractures the surface also, and surface fracture particles are generated. Because thousands of particles are striking a surface, so erosion occurs. Erosion. This process is erosion. Okay. Okay, it can also be termed as abrasion. And then the same gas help us remove both the abrasive as well as the workpiece particles away. Okay, so this is the function of gas abrasive mixture. So the jet velocity is 150 to 300. Oh, that's quite high. 150 to 300 meter per second. In abrasive water jet machining, it was about 90 meter per second. Okay, and the pressure is equals to 2 to 10 atmospheric pressure, atm, 2 to 10 times the atmospheric pressure. The preferred abrasive material is aluminum oxide silicon carbide. Applications are deburring, etching, cleaning of hard vertical material alloys, non-metallic material, germanium, silicon, glass, ceramic, and mica. So these are some of the applications and materials which are used for machining through abrasive jet cutting process. So this is all about jet cutting. Okay. So jet cutting done and ultrasonic cutting also done. So next we move on to electric discharge machining. Oh, how to zoom. Okay, so we have covered ultrasonic machining and water jet machining until today, and later on we will move on to electric discharge machining through videos. Okay, so thank you, and I will see you in the next class.